In this video I'm going to use the unit circle, and you can look at my video on the unit circle, along with special triangles, and you can take a look at that video as well to see how those are created. We're also going to be looking at the cast rule. Again, I've got another video on that. So we're going to use all this stuff, these ratios, sine ratios, cosine and tangent ratios, along with their reciprocal ratios, the reciprocal of sine theta, which is cosecant theta, reciprocal of cosine theta, which is secant theta, and the reciprocal of tangent theta, which is cotangent theta. So we're going to use all that stuff. We're also going to look at the sine and cosine ratios for angles that are multiples of pi by 2. And of course there's another video on that too that you can take a look at. Okay, so these are all some little background sheets that I have here to kind of help you with along that process. And the videos will also help. So we're going to start with this this table here, and the degree part isn't really the most important part of this, but I just put it in there in case you would like a little bit of guidance to see which angles in degrees correspond to which ones in radians. So of course 0 radians is 0 degrees. We've learned that pi radians is 180 degrees, and then of course that means that 2 pi radians is 360 degrees. Then from there we just use the fractions to get the rest of the angles in degrees. So if pi is 180, then pi by 2 would be 90. Pi by 6 would be 180 divided by 6, which would then be 30 degrees. Pi by 4 is 180 divided by 4, which is 45 degrees, etc. So if you can fill that out if you wish, but I'm going to be focusing on the radian measures in terms of pi for the angles. So to begin working on the graphing of sine curve, I'm just going to start looking at the multiples of pi by 2 and get those sort of listed here. So if I look at 0 degrees, well, 0 degrees is 0 radians. This also comes from the fact that from the unit circle we know that sine theta is opposite over hypotenuse, which is y over r, and if the radius is just 1, then that means sine theta equals y. So in an ordered pair, the second coordinate of the ordered pair of a point on the Cartesian plane is sine theta, given the rotation of theta. So if we know that r is 1, then that means that sine theta is going to be 0 when theta is 0, because the radius of 1, the circumference of the circle, intersects the x-axis at the point 1, 0. And while I'm at it, I may as well just put this here for the x-coordinate of that point as well. Then pi by 2, sine theta is 1, cosine theta is 0. At pi, sine theta is back down to 0, and cosine theta goes to -1, etc. So you can just complete the rest of that table there for those. Then I'm going to go into the pi by 4s, and that uses the pi by 4 triangle here, and along with the cast rule for that. So pi by 4, and I'm going to use decimal values in this case because I want to plot the points on a Cartesian plane basically, and so it's easier to find the location of the points vertically on the grid when we use decimal values. So this is one place where I will allow you to use decimal values. So the sine of pi by 4 is 0.707 approximately, and sine of 3 pi by 4, well, it's going to be the same ratio, and in the second quadrant, of course, that's where sine is positive, so it's also going to be 0.707. the sine of pi by 6 is 0.5, and I'm using this other triangle now, the 30-60 triangle, or the pi by 6, pi by 3 triangle. So that's 0.5. The sine of pi by 3 is 0.866 approximately. Then over here, sine of 2 pi by 3, 0.866, etc. So you can just continue working on those. Remember that when you get past pi, sine is now going to be negatives using the cast rule. We go on to cosine. Cosine theta, we've got the multiples, a few multiples of pi by 2 there. Pi by 4 is still going to be 0.707. Now in the second quadrant, this is the second quadrant here, the cosine of 3 pi by 4 is going to be negative 0.707. Cosine of pi by 3 is 0.5. Cosine of 2 pi by 3, again in the second quadrant, now is going to be negative 0.5. And the cosine of pi by 6 is 0.866, and in the second quadrant, negative 0.866. Okay, please continue that pattern for those. And then when we get into tangent theta, well, tangent theta is sine theta divided by cosine theta. So we just divide these, all these values, we'll get the trigonometric ratio for tangent. So if I do sine theta divided by cosine theta, where sine theta is 0 and cosine theta is 1, 0 divided by 1, which is 0. And then if I skip all the way over here, again we've got 0 divided by negative 1, well then that's also just 0. Now here, one of the interesting ones is 1 divided by 0. Well, of course, we can't divide by 0. That will give us an undefined slope there, so that's undefined right there. Then we'll continue dividing sine theta by cosine theta. For pi by 4, 0.707 divided by that, the same thing, gives us 1, of course. Over here in the second quadrant, we divide these, we're going to get negative 1. Then I'm going to need a calculator for these next ones. So if I do 0.5 divided by 0.866, 0.5 divided by 0.866, I'm going to get 0.577 approximately. And then for pi by 3, I divide these again. 0.866 divided by 0.5 is 1.732. And then in the second quadrant, well, this ratio is going to be the same here, but in this case it's going to be negative 1.732. And then for 5 pi by 6 it's going to be the same as pi by 6, but only negative as well. Negative 0.577. So there's a few of the points. I'll ask you to finish off the rest of the table there. And then when we go over to the grids, the sine grid, the grid for the sine curve, it says that the x-axis is in increments of pi by 12, which means that each one of these points along here is pi by 12 from 0. This is actually the theta axis. It's the x-axis, but it's also theta in our for our angles of rotation. So if I count here, I get 1 pi by 12, 2 pi by 12, 3 pi by 12, and 3 pi by 12 can be reduced down to pi by 4. Then we've got 4 pi by 12, 5 pi by 12, 6 pi by 12, 6 pi by 12 is just pi by 2, 7 pi by 12, 8 pi by 12, 9 pi by 12, that's going to be 3 pi by 4, and then 10, 11, 12 pi by 12, which is just going to be pi. Okay, so continue in that manner to mark off the pi by 4s and pi by 2s, etc. Now in between, of course, 2 pi by 12 can be reduced down to pi by 6. I'll put a mark here just to indicate that I just don't want to crowd this up too much. So that's pi by 6. Then 4 pi by 12, that reduces down to pi by 3. So that's another main angle measurement that we're going to be looking at. And then the same thing on the other side here. We've got 2 pi by 3 over here, and then we've got 5 pi by 6 over here. Okay, so those are all the main angle measurements that we're going to be looking at. So please continue with that. Then it says here the y-axis is in increments of 0.5. So then vertically this is going to be 0.5, so this will have to be 1. And then this is negative 0.5, and this is negative 1. There. Okay. So I'm just going to plot a couple points here, so then you kind of get the idea. So we're just going to look at the table. We'll just look at sine for now. So at 0 radians, the sine of 0 is going to be 0. So at 0 along the x-axis, the vertical, which is sine, is going to be 0. So just put a point there. And then I'll plot the pi by 2 here. When sine is pi by 2, when theta is pi by 2, sine is 1. So at pi by 2, sine is going to be 1. So put a point there. Then at pi by 6, sine theta is going to be 0.5. So pi by 6 is right here, so this is 0.5 there. At pi by 4, sine theta is going to be 0.707. I put the point at 0.707 is halfway between 0.5 and 1, so I kind of have to estimate there. It's not right in the middle, because that would be 0.75, so it's just a tiny bit below that. So we're just kind of getting an idea, we're just kind of estimating there. And then for pi by 3, when theta is pi by 3, sine theta is 0.866. So pi by 3, 0.866 is a little bit higher, more or less like that. Okay, and then you'll just continue with the rest of that. Once you've finished plotting all the points, please draw a nice smooth curve through the points, and then take a look at some of these characteristics so you can fill out from there. Now that we've finished, or we will have finished sine theta, what I want to do is go right to cosecant theta, and the increments are going to be the same horizontally because I want things to line up with the sine graph above. So again, pi by 12, we've got 1, 2, 3 pi by 12, which is pi by 4 again. 4, 5, 6 pi by 12 is pi by 2. 7, 8, 9 pi by 12 is 3 pi by 4. 10, 11, 12 pi by 4, or sorry, 12 pi by 12 is just pi again. Okay, so continue that pattern over here. We'll continue this over here. This is going to be pi by 4 over here as well. Then, now the y-axis, I've got a few more spaces vertically, just to kind of show a little bit more of the graph, but it's still in increments of 0.5. So this is going to be 0.5, and then 1, 1.5, and 2 here. Down below the x-axis, of course, it's going to be negative 0.5 and negative 1 here. Okay, so we're going to do the same thing. The very first thing I want to look at, though, is the fact that we know that cosecant theta is the same, or cosecant x, I guess because we're using x in this case, is the reciprocal of sine x. So that means that here, when sine theta is 0, we're going to be dividing by 0. So 1 over sine theta, well, we already discovered 1 divided by 0. Well, we knew that before, but we looked at this here graphically. 1 divided by 0 is undefined. So same thing for the reciprocal function for cosecant. When we're dividing by 0, so when sine is 0, then cosecant is going to be undefined. So we're going to stick in here a vertical asymptote. And I'm just drawing it just a tad to the left of the axis so you can see it. So there's going to be a vertical asymptote there. And then I'll take another look to see where else maybe sine is 0. Well, right here sine is 0. So again, we're going to divide 1 by 0, and that will also give us an undefined value for cosecant. So then we'll put another vertical asymptote right in here at pi. And then for the rest of the values, we're just going to divide these values into 1 to get a sense of what the cosecant graph is going to look like. So of course at pi by 2, divide 1 by 1, well then that's pretty straightforward. So there's 1 right there. I'll then go to other ones that are a little bit easier. So this is at the sine of pi by 6. We're doing 1 divided by 0.5, and if you do 1 divided by a half, when you divide fractions you flip and multiply, so 1 divided by a half is going to actually be 2. So at pi by 6 here, the value for cosecant is going to be 2. And then that's going to be the same thing in the second quadrant in 5 pi by 6. It's going to be the same ratio, it's going to be 0.5 for sine theta, so 1 divided by 0.5 is going to be 2 again. Okay, and then in between, where we've got pi by 4, there's 0.707 for sine theta, and of course I can't do that in my head, so I'm going to divide 1 divided by 0.707 to give me 1.414. So 1.4 roughly is going to be not quite at 1.5, so it's going to be a little bit below that ish. And then for pi by 3, we got 0.866 for sine, so divide 1 by 0.866 and I get 1.155 basically, so so it's going to be 1.15-ish. So there's 1, it's going to be just a little bit above that. Okay, so these values are going to be symmetric about pi by 2, just like the values you probably notice here in the table. The values are symmetric about pi by 2. So these two values are the same, these two y values are the same, and those will be the same as well. I'll just ease the suspense there. And so that's going to be the same thing down here. So this value is going to be the same over here ish, and then this value is going to be the same over here. So notice that we've got a little bit of a curve here. We got these two vertical asymptotes, so obviously the graph can't continue over here. It's going to actually have to break along here. So that's in the top, in quadrants 1 and 2 of the Cartesian plane. When we go into quadrant 3, what trigonometric ratio is positive in that quadrant? Yes, which means that which one that we're dealing with right now is not positive. Exactly, so that would be negative. So that means that when we're over here in the bottom half of, below the x-axis, as we go around the Cartesian plane, as we rotate the terminal arm around the Cartesian plane, when things are in standard position, like here, when you come down into quadrants 3 and 4, then sine theta and consequently cosecant theta are going to be negative. So these values are going to repeat and they're going to be down here. There will probably, well there is, another vertical asymptote over here. Notice that these two are a distance of pi apart. Chances are the next one will be another pi away from this one. Okay, so I'd like you to continue with that and then make any sort of observations that you find there. If we move along to cosine, this is pretty much the same stuff as for sine. Again, we have our pi by 4 here, 1, 2, 3 pi by 4, then 1, 2, 3 pi by 2, 1, 2, 3 pi by 4, and then pi over here. So same sort of idea, same sort of increments. Vertical increments are the same, so we've got 1 here, negative 1 down here. And we're just going to plot the points just like we did for sine. When the angle is 0, cosine theta is 1. So in this case, instead of starting at 0, we're going to be starting at 1, the vertical value of 1. And so that's going to go here. And then we continue along here. Now, when theta is pi, cosine theta is -1. So that's going to be down here. Okay, and then when cosine, or the angle is pi by 2, cosine is 0. So we're just going to plot that point there. Okay, so please just continue working on the, after you finish working on the table, continue working on the curve here, and make sure it's a nice smooth curve as you go, please, because that's sort of what the graph looks like. And then observe some of the features of that graph. When we get down here to secant, same sort of idea. Secant x is the reciprocal of cosecant, or sorry, cosine. So that's 1 over cosine x. Same increments again. Here we've got pi by 2, sorry, pi by 4. Pi by 2 is here. 3 pi by 4, and then pi. So those will line up. And then again, the y-axis increments are in 0.5. And so then we're just doing 1 over cosine. Now 1 over cosine, well here, 1 over cosine is just going to be 1 when the angle is 0. So we're just going to plot a point here at 1. And then at when the angle is pi, cosine is -1. So we're going to plot a point here at -1. And then when the angle is pi by 2, cosine is 0. So when we do 1 over 0, like we've already seen, that would be undefined. And so here, in this case, it's where cosine is 0, similar to where sine was 0, cosecant had a vertical asymptote, but now sine is 0, or cosine is going to be 0 here at pi by 2. That means that for secant, we got to have a vertical asymptote. So the vertical asymptotes for secant are not going to be in the same position as the vertical asymptotes for cosecant, which related to the sine function we just looked at. Again, just continue plotting those points and setting those things up, please, and draw the smooth curves as you see them, please. And then we move on to tangent. Now in this case, the tangent, the x increments, or the increments for the x-axis are pi by 4. So we've got pi by 4 here, then we've got pi by 2, 3 pi by 4, then there's pi, then we've got 5 pi by 4, and 3 pi by 2, and then 2 pi over here. Then we've got negative pi by 2 on this side, negative pi, negative 3 pi by 2. Okay, and the y-axis are increments of 0.5, so we got 1 and 2 here, and then -1 and -2 here. Okay, so tangent, as we see, is the division of sine and cosine. Okay, so that comes from, again, from, if we did the tangent of this angle theta in standard position is opposite over adjacent, y over x. Well, we previously discovered that y was equal to sine theta and x is equal to cosine theta. Therefore, when you divide y by x from here, we get sine theta over cosine theta here. So we're going to use these values of sine theta and cosine theta to divide those in order to get the values for tangent theta. And so when we look at sine divided by cosine, 0 divided by 1 is going to be 0. So here at, when the angle is 0, we're going to have a value of 0 for tangent. Again, sine divided by cosine, 0 divided by -1, that's still going to be just 0. So that's at pi. It's going to be 0 again. And here we see at pi by 2, sine divided by cosine is 1 divided by 0. Here's another undefined, as we have already seen here. So you're going to have a vertical asymptote here at pi by 2. And by symmetry and patterns, we've already got a 0 here, so we can't have another vertical asymptote here. So I'm going to hazard a guess that there will be another vertical asymptote here. So all these patterns which you're seeing with sine and cosine, tangent, and all the reciprocal functions, all those patterns just keep repeating. That's why it's called periodic functions, because they keep repeating over a similar period. Or sorry, some period. Sine and cosine, they repeat over a similar period, or tangent, especially in this case, is different. So set up the values, or the vertical asymptotes, and then we divide again. We keep dividing these. So sine divided by cosine for pi by 4 is just 1. So here is just going to be 1. When you go into the second quadrant, it's going to be for 3 pi by 4, we're going to have -1 for tangent. So that's going to be down here. And then if I divide here, I'll divide this 0.866 by 0.5. So 0.866 divided by 0.5 is 1.732 for tangent. So 1.732 at 3 pi by 4 is going to be around here-ish. And then when we do the -1 here, 0.866 divided by -0.5, it's going to be the same value, but negative. It's going to be -1.732, so it's going to be down here approximately. Okay, so we can sort of start to see that the graph's going to be going up, approaching vertical asymptote. From here it's going to be coming from the vertical asymptote, and then coming up through again. Okay, so just continue that pattern. And then, of course, when we do cotangent, we're going to be looking at these again. This is exactly the same increment values. And so we got 1 and 2 here, -1, -2. And so then, now, cotangent is the reciprocal of tangent. And so cotangent theta being 1 over tangent theta, that's 1 over sine theta over cosine theta, which then just flips sine theta and cosine theta. So cotangent theta actually ends up being cosine theta divided by sine theta. So then now for the cotangent points, we're just going to take cosine and divide by sine. So for the angle of 0, now we have 1 divided by 0, so that's where the vertical asymptote is going to be for cotangent. It's going to be right here on the y-axis, or where the angle is 0. When we divide at pi, we're going to divide, again, -1 by 0, because it's cosine divided by sine. Again, we're going to get a vertical asymptote here at pi. And where we divide cosine by sine here, 0 divided by 1, well, at pi by 2 it's going to be 0. Okay, again, notice now that for cotangent, the vertical asymptotes aren't in the same positions as they are for tangent, and the position of the curve at any value when it goes through the x-axis is not going to be the same as it was for tangent. Okay, so please continue with that process for the graphs and the tables, and then there's going to be a table. The very last page is a table that you can fill out for a character of all those graphs.